everyone's wants to know the magical stack that you should be taking, which in some way, I think is the least important thing right now. Most important is I hate to talk about immortality because frankly, it's crazy. I've said, if you want to be immortal, go to church. The winning group will have found a human intervention that increases lifespan or life expectancy or health span by 10 to 15 years.
Welcome to the Beyond Tomorrow podcast. My guest today is Eric Verdin, the president and CEO at the Buck Institute in San Francisco. He is also one of the leading longevity professors out there. We caught up in Riyadh at the GHS Summit by Hevolution earlier in February. In this episode, we cover everything from the latest developments in longevity science, what Eric is taking and what he recommends you take when it comes to supplements and other protocols to help you live healthier, and also a milestone that he talks about that could potentially radically extend yours and my life by up to 20 years. And that milestone will be happening, hopefully, in the next 5 years. The reason I started this podcast was to give you a trusted place to hear about the latest innovations, ideas, and concepts that are helping you live a healthier and more prosperous tomorrow. Every Tuesday at 8 a.m. in the UK, 3 a.m. EST, we're going to be dropping a new episode. So if you want to be the first to be notified of episodes with Christian Angermeyer, Aaron D'Souza, the founder of Enhanced Games, Nidhi Pandya, and Peter Diamandis, please feel free to hit the subscribe button. Now, I hope you enjoy the episode. Let's dive in. Eric, thank you so much for being here. So we're in Riyadh for the Hevolution conference here. It's pretty astounding what they've done so far, and we're going to definitely dive into that. But recently, you were on a Dr. Mark Hyman podcast, and he asked a question around how did you get into this aging field? And 25, I think the quote was 25 to 30 years ago, it was the backwater of medical research and innovation. So what drew you to aging? And were you seen as a bit of a contrarian at that time?
It was, in some way, it was happenstance in a way that I was working on HIV and trying to understand its epigenetic regulation. We ended up cloning a family of genes that were turned out to be involved in aging. Yeah. And so, having worked on HIV for 20 years, I was a little tired. I felt that we were somewhat turning in circle. My lab, not necessarily the field, but turning in circles. And I thought, okay, I need something. And then these papers came out from Lenny Guarante and Shini Mai showing that the proteins that we were studying were involved in the aging process. And I started reading about aging, and I realized, wow, it's not only that we don't not only have something that has direct relevance to aging, but there's something happening in the aging field which is completely different from what I had seen before. And so slowly I shifted my lab in that direction pretty quickly, actually, over like the next 2 or 3 years. I still have one person right now working on HIV in my lab, believe it or not, but most of our effort now is really focused on understanding the aging process.
Can you just delve into that inflection point?
Yes.
Because I feel like we're nearing another inflection point. So there was clearly an inflection point that happened. Was that in the 90s or the 2000s?
Yeah, that was mid-90s.
Okay.
The inflection point was, so aging until then, had a lot of courageous people who were working on it, but it was considered by many in the field to be, the revolution had happened in terms of molecular biology and mutation and genetic engineering and all of biology. It was sort of left out of the way in aging research, right? Aging research was more phenomenology, sort of. And what a number of groups did in the mid-90s, Tom Johnson was the first one in Colorado, identified the first mutation that increased lifespan. Before this, people thought mutations typically are associated with a loss of function. Yeah. That was the whole, and all of a sudden you made a mutation in yeast, in C. elegans, in fruit flies, and the life expectancy would double or triple, quadruple. just really shook the whole field of aging biology up. And I think we've never looked back, because it just highlighted the fact that, like anything else in biology, there are unique genes that are playing critical roles. So that was really one of the biggest inflection points. So you can study now aging with using the modern tools of molecular biology. Initially, people thought these were exceptions. You found this gene and these are exceptions. Turns out in C. elegans, you can find 700 genes that actually are regulating lifespan at some level. So really rich biology. The second inflection point was what we've called the geroscience hypothesis, is that these mutations that are driving lifespan, or these genes that are controlling lifespan, are not only controlling lifespan, they're controlling health span. And since we know that in humans, aging is the biggest risk factor for a whole series of disease. I learned this in medical school when we studied heart disease. What are the risk factors? And there were two boxes: modifiable, unmodifiable risk factors. The modifiable risk factor for heart disease, for example, would be cholesterol, blood pressure, all the things that we know, obesity and so on. Non-modifiable risk factor were age and gender. And so now we have a handle on aging. We know how to tweak it. We've identified some of the dials. It just highlighted the idea we're not only going to be hopefully making people or animals living longer, but living better, more healthy. And that's the whole geroscience hypothesis. Now, the power of this is that since age is the biggest risk factor for not only heart disease, but cancer, neurodegeneration, Parkinson's, Alzheimer's, all of these diseases. Now, instead of playing whack-a-mole medicine where you're hitting all of these diseases as if they were independent occurrences, you have the potential, by targeting a unique pathway, aging, to modify all of them. And this is what Hevolution has really got for the first time to a really deep level. We can actually address all of these chronic diseases of aging by targeting aging pathways. For me, this is a dream come true in a way that, like anybody else, I want to live longer and health, but I want to mostly live healthier.
Yeah. So the Buck Institute is well known across the world as the leading institution in the aging space, right? And you've built this great partnership with Hevolution here in Saudi, that is the largest donor, one of the largest donors of the institute now.
It is one of the largest donors. Yeah, we've had really significant support from the U.S. government, from private donors, but definitely, this $22 million grant does not happen every day. It's definitely one of the largest, and really one that's completely aligned with what we're trying to do. So I could not be more excited to be here and to work with them.
The reason why I bring it up is aging is, or the elixir of life, a magic pill, which we're far away from, will destroy many business models, right? Destroy is quite a strong word, and so the incentive of a lot of pharma companies isn't quite there to support research into aging therapeutics, etc. And then you also have venture capitalists at the moment that are somewhat refraining from investing in aging biotechs, etc. So how important has public funding from foundations like Hevolution been for the aging space?
It's critical. You're totally right in your analysis. And the people who are in the field and who've been in it for a while, we're so excited about what's happening. And it's a bit hard to understand why it's taking so long for the whole field to come in. But that inflection point is happening. I can definitely feel it in terms of interest. And when you have a massive foundation like this one coming in and really spearheading this, we had the head of GSK on stage today at the meeting. So that tells you they might not have made the investments, but they're paying attention. And there's a lot of discussion on how, related to this is, why is that? Why hasn't the whole world really jumped onto what's happening? I used to say that, and I'll try to address it, what I think is happening. We used to say that, this was going to change everything 20 years ago. But I've talked to a number of people who have described, the history of what I call revolutions. When a complete paradigm shift happens, it takes a long time for people to get on board. I also try to remind my colleagues in the aging field who are even more impatient and more optimistic than I am that as a field, we haven't delivered a single drug to the market yet. When that happens, there's going to be a tsunami that I predict, because there's still a bit of suspicion. Who are these people talking about Healthspan and these geroscience hypotheses? It's all so different and foreign. And frankly, and I'm not judging here, there's a whole economic order that exists on a completely different model. Yeah. Is that, right now people are getting sick. We come when the disease process is at its conclusion in some way. When you get a heart attack, this is the end of a process that was initiated 15 years earlier. And there's a whole industry and this, again, I'm not judging, this is the existing order. Physicians, hospitals, care, pharma, biotech that exist on, maybe trying to prevent it a little bit with the statins and mostly treating it. So, and we're coming and we're saying we want to disrupt all of this. We want to prevent all chronic disease of aging. I think we will do it. I used to say that we should reform the system. I don't think we should. The system has too many economic interests that make it really self-sustaining, and it's good business model if you're in it, that we have to disrupt it. Yeah. And the disrupt it is really not judging. I tell people, if you have a heart attack, God forbid, or if you get a cancer, God forbid, don't come to see your longevity doctor. He's not going to be able to help you. It's too late, and medicine does an amazing job at doing this. But how can we actually prevent this from occurring at the first place? And this is really what the whole field of longevity medicine and health span research is coming into, is really changing the whole paradigm so that aging is not necessarily associated with what it is today. When people reach 65 years old in America, 70% carry at least one of the chronic disease of aging. Heart attack, stroke, Alzheimer's, Parkinson, type 2 diabetes, many forms of cancer, macular degeneration, sarcopenia, hip fracture. Miserable. I've seen this firsthand with my parents, aging and suffering, having the last years of life after you've raised your children, sort of being diminished by your inability to do everything that you want. And so we want to change that equation, and I think we will.
I find the paradigm shift, I don't know if the Overton window is the right phrase to say here, but it's shifting so fast. If I told someone 2 years ago, I'm interested in the longevity space, they would look at me like I was a narcissist who wants to live forever, right? And now it just seems that the world is shifting so fast, so I'm not surprised. But to talk about Healthspan, seeing all the documentaries coming out, it's becoming more of a norm to embrace all of this happening. So you've got that shift. And then also, I think David Sinclair, the longevity professor, very well known longevity professor, was saying that a few years ago, you could only do one test in a few days. And now you can do trillions in a few days. And so with AGI, some people talking that AGI could be coming this year. How far could we be moving the needle in longevity over the next few months, let alone a few years?
So let's talk about longevity versus, health span versus lifespan, because this is a critical distinction. I'll make a little bit of an aside on this, because that's one that I feel very strongly about. Longevity space is big. It has people who think we're going to become immortal, and it has people, a little more conservative people like me, who are claiming, hey, not so fast. First, we don't have any evidence about this type of language. I think it's a big tent. Everybody has the right to say whatever they want, but I feel that I have to say my piece, which is, I think, pushing the envelope in terms of increasing lifespan dramatically. We've done it in animal models. There is nothing right now that allows us to say whether we're going to be doing this in humans. So I refrain, for example, from type of statement that we're going to live to 150 or 170, because You can say it, but where's the evidence? Where's the proof? What is, so you can say anything, and I'll beat you because I'll say I'm going to live to 20. I have no idea. I would love it if I could be in good health. The reason why I refrain from this type of discussion is, first, there's nobody that has any evidence that they're going to be able to do that. The second one is there's a pretty strong evidence there's a hard limit at human lifespan right now, which is 115, based on all of the evidence on billions of people who have lived on Earth. So that would be, for most people, a really hard limit. But also, especially for me, it detracts from the amazing thing that we can do. So talking about the future is great and exciting, but what about making everybody live to 95 in good health versus 65 today? That, to me, is where the energy should be on, focusing on, because, God knows what's going to happen in 30 years from now. Those people are going to come to 90 and there will be new technology, and then we can keep pushing the envelope. So it's nice to talk about the future. I tell people it sells books and it generates clicks and helps you to sell supplements, but it also detracts from the hard work that needs to be done. As right now, most people live to 65 in good health, and I want to bring this to 95. That it's, at the same time, it's being underestimated the power or the transformational effect of such a change would have on society. From 65 to 95. I mean, I would sign for it immediately. God knows what's going to happen in the future.
Let's go to the Bunk Institute.
Yeah.
What are the most exciting projects that you feel are going to move the needle most in the next few years?
I mean, you're asking me to pick between my children. So the BUC, in some way, if you think about it, we have 300 people working on aging. It's an amazing organization. I have an incredible privilege of leading it. I think I really feel that going to work is an amazing experience because we're all focused on understanding aging and really pushing it to the next stage. Aging is a pleomorphic process. It is very complicated. There's not a single gene of aging. There's not a single drug that's going to cure aging. It's going to be a really concerted effort on multiple directions. And so we study pretty much everything. So we don't have a favorite, we have a bit of a favorite hallmark on aging, which is senescence. And this was linked to the fact that one of our late faculty member, Judy Campisi, who unfortunately passed early this year, was the pioneer in the whole field of senescence. So we have a lot of groups working on senescence and on senolytics. We were part of the initial first company in the senolytic space called Unity. But beyond this, we have faculty working on metabolism, on stem cells, on autophagy, on protein folding, on Alzheimer's. So we have, with 300 people and 22 different faculty, we're not putting a bet on one really unique aspect of the aging process because we all recognize that it's going to be a composite of all of these variables. And to understand aging, you really need to address all of them. So again, it's very hard to say what is the most exciting thing that's happening. A recent addition is really one that excites me right now is the fact that we've recruited both Lee Hood and Nathan Price with the help of the Hevolution Foundation. They are adding a whole new sort of large data, big data, AI interface to the Institute, which I think we've entered a whole new phase of biology, which is what we call network biology, where we're not looking at individual genes as if they were doing everything. We're looking at their interactions. When you do this, you enter a realm where the complexity is almost beyond our minds. I can look at a data set with maybe 20 data points. When you show me a data set with 100,000 data points, I can't look at this. So I need for AI to look for patterns. We need to correlate different data sets to see if there are shared patterns. So we've entered a totally new area of biology. Recruiting Lee Hood and Nathan Price has been really instrumental in doing this. We also have, David Furman, another faculty member at the BUC, is playing a big role in all of this. The bioinformatic aspect, or the computer aspect of biology is really becoming very dominant. And we are really trying to push the Institute to become a leader in this as well.
When you look at networks, bioinformatics, large biological models, at what point do you think other institutions will start speaking to one another and create almost this mycelium web of knowledge and data so you can really fast track these drugs into market?
That's a good question, and that's really something that speaks to the competition in science. Science has this really a unique way of being both incredibly collaborative and incredibly competitive. And so, of course, you want to be the first one to make the discovery. But we've entered a different stage of biology where when I started about 40 years ago, your typical paper would have the principal investigator and the student. So there would be two people on the paper, two or three. Right now, most papers have like 10, 20, 30 people because you just can't do everything by yourself. So we find collaborators, which are usually friends and people that you trust, and you collaborate. A good example of this is the so-called Biomarker of Aging Consortium. That's including colleagues at Harvard, Vadim Gladyshev, Mike Snyder at Stanford, our institute at the Buck, and we're working really close together. We're writing papers, competing for grants. So there is, having a giant sort of network of everybody sharing everything. I don't know, maybe that will happen one day, but I would say probably not, because it's going to be a human competitive. So you're going to see larger and larger groups working together, but still competing against each other, because that's part of the fun, frankly. You want to be the first one to make the discoveries. That being said, research organizations like the NIA, National Institute of Aging, or Hevolution also can play an enormous role by creating repositories. So, for example, if you publish a paper with NIH support, you are obliged to actually deposit your data in a very large data set where everything is. And so that, a lot of, think about UK biobanks, same thing, enormous resource that everybody is using. So this is where foundations, granting organization, countries can play a role of accelerating this. So you can still have the benefit of the primacy of your data for the first year or two, but once the paper comes out, then everybody knows, has it, and can actually continue to mining it. So I think it's a mixture of both. But frankly, I love the competition and I love the collaboration.
Eric, whether you like it or not, being a longevity professor leader means that the spotlight's going to be on you, especially with your protocols, what you do on a day-to-day basis.
Yeah.
And I know recently there was an article that said you have a very small stack, right? You take five things. It's vitamin D, vitamin B12, omega-3 fatty acids, and then creatine.
Yeah.
It's 4. Okay.
Yeah.
Is that your go-to every day? Do you have anything else that you add to that stack? What are you doing to reduce senescent cells, and are you doing anything around autophagy as well?
I do a lot, to be honest. And I think I like the way the article came across, because they didn't discuss all the other things that I'm doing. But the point of the article, which was the fact that this is a unique stack that pretty much everybody should be taking. You should have your vitamin D level, vitamin B12 level. You should probably take omega fatty acid. And actually a paper just came out showing that that those combination of the three, I think D, B12, and omega fatty acid actually increase your lifespan, at least changes your clock in a positive way. Not by a huge margin, but it does. So,
why do you need to take these? Like, why are we at a point now where it's important that every human has to take these supplements?
Because they are the ones, so there's deficiency that's really linked to aging. B12 and D are really affecting some central mechanisms. Same for omega fatty acid. They're, critical for every cell. And we have lots of epidemiological evidence that, different lifespan associated with different levels, but also clinical trials where you supplement showing that people get benefit. So I think this is sort of a really minimal stack. Some people in the field are taking a lot more, up to 100. I think that's where I'm not crossing that line. My approach is essentially in combination with longevity clinics with whom I work, is to make an intervention for 3 months and then test and then retest. And every 3 months I go through a cycle of things, and I find some things actually are making it worse, some that are making it better, and hopefully get to a point where I'm feeling healthier and healthier. The thing is, everyone's wants to know the magical stack that you should be taking, which in some way, I think is the least important thing right now. Most important is we go back to the basics, is nutrition, physical activity, sleep, human connection, stress mitigation. And I think I really look at those. For me, that's the majority of my effort and my focus, because I think this is what we have today. And I tell people, we can all hope for this drug that's going to pop up in 5 years or 10 years, or we can take rapamycin and stuff, or others, but those are not proven. The other things are proven, and they have really profound effects. It's hard for me to even say this, because I think people look at me like, he's crazy. I have more energy than in my 20s right now. And
was there an unlock that you felt, because you're testing so often? Was there a moment where you thought, this stack or this exercise routine or this stress mitigator allowed me to feel even more energized?
It's been progressive. And I have the feeling that I haven't reached it still keeps getting better and better. And at the same time, I meet friends who are my age who are telling me I'm slowing down, my reflexes are not this, I don't have the energy. It's all negative. It's all, I'm forced to retire. And it astounds me, because I'm realizing this is the power of this. And imagine that I had started, when I was in my 20s, I was smoking cigarettes.
Me too, so don't worry.
It seems almost impossible for me to believe, but that was the culture. We really didn't care, drinking too much and partying and smoking cigarettes and all this. Now I'm realizing, in some way, not that I've missed any, I've always tried to be healthy after this, once I quit smoking, to always exercise and so on, but there is so much more potential in everybody's life that to me, it's astounding to discover this at 68 and to realize, wow, I'm going to go, hopefully I'll continue going this way. And at some point, that's the other thing, I hate to talk about immortality, because frankly, it's crazy. I've said, if you want to be immortal, go to church. Everybody wants to be immortal, but it just, the idea that we're going to be able to do this is just ludicrous, frankly.
Can we just touch on that? Because stress mitigate, we have so many tools for sleep and diet recommendations, but what you just touched on, the power of a higher being, God, religion, and then linking it to stress mitigation. What do you do for stress mitigation, and what are you seeing working? Because purpose and community is so important. And we've just lost sight of that as well, especially community.
And from epidemiological data, there are two biggest predictor of your life expectancy, which I find amazing. More important than just what you eat. So the number of loving relationships that you have, and your sense of purpose. Why are you here? Is it just about yourself? And that. So in some way, they are the least studied, but I would say the most interesting, because they have the biggest effect. Now, why are they not studied? We cannot model them. It's very hard to model them in animal models. You look at a mouse and say, what's your sense of purpose? And I can guarantee you one thing is that the way we study animal models is not conducive for them to have any kind of joy of life. When you're a free mouse and you find yourself living in a plastic box, I really worry about the validity of these models in this respect. So now the question is, actually, we're trying to build at the Buck Institute a whole new center based on the psychobiology of aging, because these factors that we say, okay, this is self-science, human connection, will have biological substrates. There's a good example. Oxytocin, for example, is a hormone that is involved in lactation, but is also involved in human bonding. So that's the love hormone, the bonding between the mother and her child, but also affection between humans is in some way related to oxytocin. We know that has an effect on lifespan in some animal models. How many other of these chemical everything in us is driven at some point by chemical, signaling. So what are these markers? Can we modulate? Can we actually recapitulate some of these effects? we see right now in the US an epidemic of loneliness, which means we have the opposite. People are actually living shorter. And so I'm passionate by this whole area. And we're trying to build the first program that's going to be focusing on this whole psychobiology of aging and really go one step further and address this important question.
Thanks for tuning in. If you're enjoying the podcast so far, please feel free to hit the subscribe button below. It makes a huge difference. Now, let's get back to the episode. Let's quickly talk about there's a lot of noise around GLP-1 agonists and rapamycin. I spoke to Brian Kennedy recently, and he's one of the 100,000 people around the world that's taking rapamycin right now. This all feels like the Wild West. I saw a peptide book, and I asked Brian, and he didn't know many of them as well. Where do you start? Do you avoid? Do you pause and just allow things to be better researched for a bit of time?
I've experimented with many of these things, by the way, personally. So I'm not opposed. First, there's a personal agency, which is in some ways different from your traditional model where your doctor actually knows better and will decide for you. I think we're seeing a dramatic shift in this respect, and I think it should be encouraged. But to some degree, and I think under medical supervision. So I think we see a number of physicians that are much more open to the idea that if you want to try, and I can help you to guide you to understand what is the effect of this molecule on you, why not? Who am I to decide? If you're willing to take the risk, it's your body, but you should be able to take the risk based on information that I'm going to provide you. Now, rapamycin is a really good example in point. Sort of, the drug has been approved. It's given to a subset of patients at high dose for suppressing transplantation. The aging field proposes to use it episodically, not every day, and at lower dose. I've taken it. It has mild immunosuppressive effect that I can definitely detect, which worried me a little bit. On the other hand, if I go for a long run, 2-hour run, I know I can guarantee you the next day I'm immunosuppressed too. I have the same symptoms that I would get, from rapamycin. So if I decide to take it and I'm being followed and measured and so on, who is there to decide that I should not be doing this? So I think we're seeing a shift. And some of the longevity clinics actually are going in this direction, allowing, to a subset of patients to take some limited risk under medical supervision. Now, I'm a lot more worried about, what we see proliferating in some of these sort of online telemedicine where you can talk to someone and will prescribe you, rapamycin and go on your own and good luck. So that is scaring me. Doing it under medical supervision, I think, is a completely different, because some of these medicines can have really serious side effects. Yeah. And I think we're seeing a shift, and I think the aging field is really becoming a driver in this idea of personal agency. This is your health. If you want to take some mitigated risk, you should be allowed to do this, and the physicians who help you to do this should be supported and respected, because in some way there's also a potential of I'm convinced that a lot of the interventions that we will have in the future will be customized based on your numbers and my numbers. And so imagine a world where I have all these biomarkers of aging that I can tweak and can measure, and you come to see me and we'll say, we'll start with first-line therapeutics, metformin, for example. And then we see your numbers get better. Wonderful. All these numbers are predictive. You're going to live 5 years longer. Well, what can we add next? So we'll add rapamycin. All of a sudden, your numbers go down. They might go down for you. They might go up for another person. So there is going to be, and we all react to even lifestyle interventions and drugs in different ways. So that's really one of the things that's been missed in traditional medicine, is this whole idea of precision medicine. So we're right at the stage where we are developing the new tools that will allow us to do precision medicine. And I envision a world where you will start seeing your physician at age 30 and, in a regular basis every 6 months, and you will be reviewing your lifestyle, measuring your biomarkers and trying to see, okay, what is your trajectory? What does it look like? Are you looking like you're going to be done at 80 and start being sick at 60? Well, we'll start intervening and guiding you in one direction or the other. So I'm excited about the idea of implementing a true preventative medicine agenda. And that's what when people talk about Healthspan, it's about a true preventative medicine.
Before we get there, what could Pierre in France or Emily in America do in terms of measuring? If they're going to take Ozempic or a GLP-1 agonist or rapamycin, like, is there something that they have to do? Blood tests, a certain biomarker?
I would say a whole set of biomarkers, the ones that we have today. But again, those you can buy them. You can buy them on the internet, and they will come to your house. I use these markers all the time. I can tell you they vary from, I'm between 25 and 70 years old, depending on which biomarker you use. Of course, like anybody, I'll say the one that I'm 25 and believe it. It's nonsense. I mean, so these markers by themselves, if you buy one marker on the internet, I would argue has really no meaning. You need to look at the context of the whole biology, which is not only the biomarkers, but also what are your biological markers that you have? What does your wearable say? What is everything? So it's a medical problem. It's not just buying one little test and hoping that it's predicting what's going to happen. I think you need a comprehensive assessment. And this is where I do a lot of work with longevity clinics, and I think they've been criticized as medicine for the healthy and the wealthy, which is not what they might be now, because they need to actually have patience and to be able to sustain themselves. But the long-term vision is that these clinics are going to be the medicine of the future, and the costs are going to come down, and we're going to learn what is the best way. Because frankly, biomarkers of aging, we have hundreds right now, hundreds. And some of them are things that you can get from your blood. Some of them are going to be likely coming from your wearables. Some are going to be coming from your functional tests. People don't talk about functional tests. One of the strongest predictor of your life expectancy is how healthy do you think you are? 20 question questionnaire. The people will ask you, how healthy do you think you are? That predicts your lifespan plus or minus 3 years. I said, wow. We don't need fancy, because people know intrinsically when they are acting healthy or not. They know how they are with respect to their peers in terms of function and so on. So it's really interesting. The same thing is, facial recognition. People look at you and they say, this guy looks young, or he looks, this is a biological clock. When you're looking at someone, you say, this person looks vibrant for their age, and you have the feeling, well, that person looks kind of younger than their age. You have a built-in biological clock in your head that's built on you looking at a lot of people of a given age and making assumptions that are based on the average, basically.
Eric, before we finish, thank you so much, by the way. What are your thoughts on RFK? I know you mentioned stem cells and a number of areas that you're looking at, but what can we expect in terms of deregulation in the US that will fast track, hopefully, some of the team's work in San Francisco, but also across the country in terms of drugs coming to market quickly? Yeah.
So first, let me just say, there is a myth that the FDA stands in the way of innovation. One of my good friends, actually one of my first students was Ned Sharpless, who was briefly the head of the FDA. And we've had many discussions about this. He said, aging field is going around spinning its head, talking about the fact that the FDA is in a way it blocks innovation. There's nothing further from the truth. And the best example is the TAME trial, testing for metformin, was approved by the FDA. So once scientists can get together to go present something to the FDA, they will support it. So I think there's this myth that that our work is being hampered by the FDA. First, not true. Second, there's this other myth that calling aging a disease is going to open the floodgate of investment. Not true either. First, aging is not a disease. I've said this many times. It's a risk factor for disease. Imagine a world in which everybody who's 21 years old is considered sick. Well, it just doesn't make any sense. The public doesn't want it. Physicians don't want it. Nobody wants this. And it doesn't really add anything because we have many conditions that we treat that are not diseases. High cholesterol. We give medicines that are approved like for contraception. That's not a disease. We have a medicine for it. Benign prostatic hypertrophy, enlargement of your prostate, is not a disease by itself. We treat it. So there are dozens, actually, of conditions that are not diseases that we are treating with medicine, FDA approved. Now, why is the FDA important? Because once you unleash something on the whole population, if one person, think about the number of complications we have from vaccines, which are some of the safest medicines that we have today. One person out of 100,000 will die. Well, think about all the controversy that this creates. The same thing if a large pharma has one drug that kills 2 people. This is creating, now think about, removing these regulations and allowing people to self-experiment in a way without supervision. And imagine all of the problems this could lead. This will create a huge backlash against our field. So I think I tell people, the FDA is there for a good reason, which is to help that the drugs that are on the market are safe. And I do worry, frankly, about our field having some adverse effects. And I'll just remind everyone about what happened to gene therapy. About 25 years ago, it was going to be the panacea. It was going to cure everything. And sadly, 2 young individuals in their 20s were killed by a gene therapy trial. It killed the field for 20 years. Nothing could be done. So I think I would urge some level of caution as we move to pushing our agenda. And I'm as ambitious as anyone, but I also have seen this happen before, that let's not get ahead of ourselves. We're in this for a long-term gain. And I think by showing that we understand the risk of what we're proposing, we will establish ourselves as a serious force for good in the future.
I hope you're enjoying the episode so far. As we're such a new podcast, every single subscribe and follow makes a huge difference. So if you haven't hit the button already, please feel free to do so. Now, let's get back to the episode. So, what is something you believed in the field 10 years ago that has been completely debunked?
It's actually, I would say, nothing, in the way that it's been, what we've seen the opposite in a way. So we got hints of things that were going to happen, that we felt like the neuroscience hypothesis, this whole idea you could, this was, there were a number of really sort of daring hypotheses that were put. And in the last 20 years, what we've seen is what was considered by everyone crazy, the idea that you could regulate aging with a single gene, when aging was considered a sort of a multiform pleiotropic effect. And all of a sudden we find out we have these targets, these dials that we can tweak that change aging. So in some way, when you're in a field that really is revolutionary, and I don't use that term lightly, but really what happened about 25 years ago was a revolution in our understanding of aging. At first, you dream, you have all of these ideas, and all of a sudden you realize, no, this is actually true. Because, of course, as a scientist, our job is to be incredibly daring about our own ideas and incredibly critical about everybody else's idea. Always something that is one of the paradoxes that always amused me the most in a way. For most of my colleagues are the most creatives are so creative and daring about their own ideas, is so critical about everybody else. So that's how science works. So you need to be able to project in the future. And then you need also to subject yourself, but also all of the other colleagues even harder to your skepticism. And one of the things that has happened in the last 20 years is really the incredible validation of these daring few early papers. And we can, tweak aging. I mean, there's right now, every other month, there's another paper that I'm looking at. Is like, really, this is amazing. Like interleukin 11. I've never read a single paper, and I'm an immunologist, about interleukin 11. All of a sudden, blocking it suppresses aging. The whole reprogramming is amazing. I mean, there are so many things popping up left and right. I could spend my full day just, looking at the literature. And I have a number of alerts on Google and other areas that alert me when there's a paper about aging. And my mailbox gets filled up every day with interesting stuff to read. So it's an extraordinary time with a tsunami that I think most of us really are still not measuring what's going to happen. But, that's so more than being disappointed and having to say, well, I have to change my mind completely. I really cannot think about a single thing that we got a hint of that has not come to some degree to be realized.
And a final question. I want to give you a crystal ball. Your crystal ball. I want to go into your crystal ball, I should say. Well, by 2030, where do you think we'll be?
By 2030, the X Prize will have been announced. And I would say the winning group will have found a human intervention that increases lifespan or life expectancy or health span by 10 to 15 years. So that's by 2030. This is pretty quick. And that intervention will be either a drug or it will be a combination of, and this will be profound. So, I want to applaud like Peter Diamandis and the X Prize for really taking this as an agenda, because the field needs it to show that we have to stop talking and we actually have to really do the clinical trial to show that the validity of what we're doing. So I predict it will be 10 to 15 years. I mean, if I want to be really dreaming, I would say someone will find something that's 20 years. And then you realize, okay, we're accelerating the field, because if you can deploy this on a global scale, imagine the consequences in terms of everything. It also will unleash the floodgates in terms of talking about VCs and big pharma being on the side and waiting to see what's happening to this field. I think it will be amazing. We're seeing them coming in now already, because they've seen the writing on the wall. This field is moving forward with them or without them, and this is going to be. Think about what's happening with the GLP-1 agonist. People are predicting $150 billion market for these drugs. Longevity is going to be even bigger because it affects everybody. And so I think my crystal ball is, even though, I hate to put a number on what's the maximum life expectancy and how long are you going to live, am I going to live, I have no idea. What I can tell you is that by the end of the decade, we will see some really significant acceleration of this field.
We're clearly on this exponential curve up. We started the conversation talking about that inflection point in the 90s for you, and now we're on this curve as well.
Yeah. We're on the hockey stick, absolutely. Yeah.
Eric, thank you so much.
My pleasure. My pleasure. Thanks for having me.
Thanks for listening to the Beyond Tomorrow podcast. Your support helps this journey reach more people. So if you've enjoyed it, please share, subscribe, or leave a review. See you next time.